Thank you, Andreas. Fascinating stuff. So we see that, could we have the presentation, please? We can see that evidence is rising. We've had some, some evidence in the past that, microprocessors indeed do profit, or amputees with lower mobility do indeed profit from microprocessor-controlled knee joints. And there is more evidence on the way. As we learned last year, AOPA, there is an AOPA-sponsored study confirming this, and we will see later some very interesting research from Dr. Domeyer. But isn't it actually to some extent funny that we're asking ourselves this question in the first place? Where does it come from that we actually think that amputees with lower mobilities should not profit from a microprocessor-controlled knee joint? And we do know there was a very renowned cohort of authors that updated us last year with their systematic review, that there are factors that indeed support an amputee to become a prosthetic walker. So if you're high in motivation, you have no phantom pain, if you get to rehabilitation early, which is one of the most important criteria, you're free of vascular disease and you're capable to stand on one leg, then indeed, the likelihood that you will become a successful prosthetic walker is high or higher, while as to whether or not you smoke, as to whether or not your body mass index is not ideally what you wish it to be, your gender, your living status, your age doesn't really seem to influence this. And we seem to somehow think that once we have successful prosthetic walkers, that some of those criteria might actually also be relevant when we transfer from a mechanical knee joint or for a lower mobility amputee to go to a microprocessor-controlled knee joint. At least that's the way that we act. Yeah, so we do have systems in where the mobility grade rating, comorbidity sometimes BMI, indeed seem to pose a barrier or a threshold to actually have access to such systems. And I'm not speaking here about any potential to possibly enhance the population of those that that were not capable to walk before. So this led to the research question. If we have parameters that we think can distinguish between who should get one and who shouldn't, can we really observe factors that have classifying power to justify such a distinction? And so what we did is we had access to larger cohorts of likely responders that underwent trial fittings in Germany. Trial fittings are a very common and validated method where an amputee is actually receiving a MPK for a limited period of time, and to show as to whether or not they can exhibit certain functional benefits. And so we were doing all sorts of regression models and looking as to whether we can find a signature that would actually allow us to see as to whether or not there are such classifying powers. We had about 1,200 CLEX. We got that out in JPO in 2015, and about 900 genomes that we published in Medicine late last year. So these are the populations, and we can see that it's the genome population is a little younger than the CLEC population, it seems to be a little fitter. And as far as etiology is concerned, it's also moved a little bit more on the traumatic side. Having said that, I just want to make us aware of the fact that these are very large samples. Data were taken for CELEC between 2006 and 2010, genome 2011, 2015, and there was quite a number of clinical workshops and processes involved in that. And then when we speak about 6% vascular disease in the genome population, that's still significantly more than we find in most controlled studies. And so we were looking at those demographic factors and checked for the outcomes. And first and foremost, there are the so-called functional benefits, as there is subjects' perceived safety, and then prosthetist assessed symmetry, relief of the contralateral side, the attention of gain of attention, and the subject's capability to vary gait speed. Those were assessed by the prosthetist on 5-point Likert scales, and this procedure was evaluated and suggested by the University of Münster and the Independent Center for Testing Endurable Medical Aids. And so the first thing that we actually do see is the number of responders is high. That's not really surprising because that is a cohort of likely responders. What's more interesting to us here is that we do have a certain variability in this responsiveness, and we do not exceed 80% in a single category. Again, the highest variability we find in a subject's capability to vary gait speed. And that allows us to actually make a first conclusion, and that is we do not see dominating ceiling effects in this sample. We have a sufficient sensitivity and difference in the different categories. We investigated in 2014 and presented in 2014 the results on the CELEC cohort. Actually, the two cohorts are a little bit different in their etiology and in their demographic factors, and so I chose to actually not mix them together, but to show and analyze them separately. What we could see is, again, we see the functional benefits, and due to the nature of the data, we looked for correlations, and we used Kendall's tau, and we can see that despite the high responsiveness, we can see no clinically relevant correlation between an individual being capable to utilize the benefits of that specific prosthesis with their age, with their mobility grade, with their etiology, or any interdependence. And if we start modeling this, and we're actually looking at the predictive power that we have in this sample, then we can see, yes, the capability of a subject to vary gait speed it's a good parameter. It tells us something about it, but is it good enough to actually base a clinical decision on it? And we can see this is very clearly not the case, because the predictive power is 9%. That means we are 9% better in if we do know this data and take it into consideration in a certain model than not knowing it at all and simply guessing. And I think that's certainly not enough to justify a clinical decision. Specifically, as we do understand, and that has also been pointed out before, that mobility grade rating itself is highly influenced by the technology that you do use. And we do understand that about 50% of the subjects that underwent the trial fitting and that were originally rated mobility grade level 2 prior to them being put on the new technology were reassessed mobility grade 3. And that is, interestingly enough, very much what we saw before. So we have very similar numbers that were presented in the literature, and to the vast amount of subject that we have in here, the confidence interval of this is relatively narrow. Now, for Genium, we took a little bit of a different approach, and we said we would like to check a lot more parameters and a lot more variables to actually understand what the power is that we find in there. Like, and you can read it, age, years wearing a prosthesis, and so on and so forth. And I show you one example of this setting. This is a mobility grade displayed in against the rating in the Likert scale, and we have on the z-axis the percentage per in this per rating in the entire group. And yes, we can see there is something going on with respect, and that is the capability of an individual to vary gait speed with independence of mobility grade writing. So what we see is, yeah, there is something there. So there's substantially more in mobility grade 4 that can do it, and that can do it very well, and it's getting less in the other mobility grades. So that's something that we would expect. Again, we see that the outcome that we're using here is sensitive. And now, once we take the same data, just transfer it to 2D to run our regression model, which in this specific case is a linear model, and these lines are just to illustrate a little bit the density of the data behind the points. Then we calculate the effect estimate here, and we say, hey, that's 0.36 per unit, that's 1.44 over the entire scale. That's a big effect. That's not nothing. I mean, that is a big effect. So we can clearly see that mobility grade writing does have an influence on the subject's individual capability to vary gait speed. P is 10 to the minus 26. I mean, what shall I say? I mean, this is very clearly non-coincidental. That's a very clear effect. And at the same time, we look at the correlation coefficient, and we do understand that this is certainly not enough to allow us to create a model that will exhibit predictive power. So we understand there is an influence, and the influence can be measured, but as to which extent, if we have a certain individual that has mobility grade 2, we can predict their capability to vary gait speed. That's not possible. No? And we can see that. So there's one point I just wanted to make, and that is we're using the results being denoted on Likert scales here. And it's absolutely with no doubt that absolute functional measures would have helped and would have been more, give that still yet another quality. On the other hand, I found it when we ran through that very remarkable how Likert scales are in the first place. And sometimes we seem, we forget that Likert scales themselves are very valid instrument, and the mathematics behind it is fairly robust. And so this is the same thing. We just have a compound measure of functional benefit here, and just to illustrate again the dependence on the mobility grades and the variability that we see over here. Now, we did that with all the parameters, and the first thing that we found was that there is a hierarchy in parameters. So not every outcome is the same. And so we were looking at those that picked up most confounding effects statistically. And again, we saw that amongst the functional benefits, the capability to vary gait speed is the highest, and that's not surprising. No? Then we understood, and that was a little bit of a surprise to us, when we looked at the subject's perception categorization, we understood that toileting is the one parameter that is actually most sensitive to pick up influences of other factors. And once you come to think about it, then you suddenly understand, well, actually, toileting is a fairly complex movement. You navigate in very narrow space, you turn yourself around, you find yourself, as you have to stabilize yourself, in a very vulnerable and delicate situation. And if you have a problem of any kind, it will show up, and that's what we see. We look at the, in the category that is called advanced maneuvers, amongst others, on the capability of subjects to reciprocally ascend stairs. And when we stratify that in that sample, we understand that we have 73%, and that also fits in with what has been observed prior by Aldridge, Highsmith, and Bellman. That is also just to calibrate this sample a little bit. Now, these are the results of the regression models, and we have published that. No worry, we're not going to fight through the numbers, but I would just like to read out a few of the key findings that we took from that. Interestingly enough, we saw that females seem to perceive their status better, so it seems that females don't complain so much, despite even they were rated in some areas less favored than their male colleagues. People who are worse off, like having vascular disease, claim to have higher subjective benefits or show higher subjective benefits, and they also seem to score a little bit higher in advanced maneuvers once they go to the advanced hydraulic MPKs, and at the same time, people who are better off are rated better by the CPOs. Ischial containment sockets function a little bit better when compared to, a little bit worse when compared to hybrid in the standard functional benefits, but were rated better with advanced maneuvers. Liners seem to work. So that's interesting. Liners seem to work. Of course, the better your residual limp is, the better your success is in functional benefits and the advanced maneuvers categories. C-leg various still profit from or benefit from genium in advanced maneuvers, 5 perception categories, and the capability to vary gait speed. And if you use a high dynamic foot, that's also good. Okay, so these are the results of the regression model, and I think it's all in its not too surprising. But now let's have a look at and we have effects, and all those effects are statistically significant. But let's now have a look at the regression modeling, because what we're actually looking for is, do we have the capability to predict an individual's capability, and therefore also to some extent predict an individual's fate to have access. And we look at the regression coefficients, and they don't really make us happy, don't they? I mean, and once we run multiple regression models on them, then we can pimp them up a little bit. But still, we are not getting anywhere close where we could possibly derive predictive power from those parameters. And that's samples of 900 or 1,200 subjects. And so I think what we can conclude is that indeed, when we look at those parameters, age, years wearing a prosthesis, gender, that we can actually exclude those parameters as having any really too high influence on those categories. And there are parameters that even cease to exhibit or fail to exhibit statistical significance, like BMI, other socket types, and some specific comorbidities. There may be one exception, and that is also interesting. Once we look into the daily walking performance, and I've printed here in the blue this compound measure of functional benefit, and then the number of subjects in this category. Then we do, divided by 10, just for scaling reasons. Then we do understand that, the number of subjects that we have here below 400 meters is really low. Huh? So yes, those individuals do exhibit functional benefit, but from a general point of view, there are only very few subjects in here. So I wouldn't really lay my hand in the fire to exclude daily walking distance. And I think that might be something for us to look at into a little bit more, detail. This work has limitations, of course. It's a retrospective analysis of likely responders. To my understanding, it's a very, very powerful sample. These are the most powerful samples that have been investigated in our field. To my understanding, the assessment is recorded on Likert scales. At least for the advanced maneuver categories, we have very distinct descriptions of the tests that actually were to be carried out. And I made my point about that. I do think that Likert scales really have a very good statistical foundation. And there was one thing that we were looking at very, very carefully, and that is the influence of possible bias that we cannot exclude in trial fittings. And we saw that we do not have dominating ceiling effects in the sample. We also need to understand that the regression modeling that we do take will actually, unless the bias will drive the regression model into saturation, we will receive still lower bounds from that, so it's still valid. And also by using the calibration points, we can actually estimate the bias to be probably below 5% in this sample. Which brings me to my conclusion, and that is actually trial fittings work, and they seem to be very powerful and also sensitive instruments, and the bias is pretty low. The responders that we looked at covered the entire range of the variables that we actually did investigate. We were a little bit surprised by the importance of toileting from a subject's perception point of view. And daily walking performance below 400 meters certainly looks something to look more into it. But what I do think that we can very clearly state is that an individual's capability to profit from a microprocessor-controlled knee joint, at least the advanced hydraulic ones that we had in this sample, is not be predicted by mobility grade, age, etiology, prosthetic experience, BMI, gender, comorbidities, previous prosthetic fittings, the socket types, residual limb conditions, and others. And so such parameters do not really qualify to justify a clinical decision, neither approval nor denial. My appeal is very clearly that we actually should cease to use them, specifically if we do mean something completely different, such as cost. Thank you very much.